Don Knuth, when he wrote Tech, one of his goals was that Tech would give identical results 100 years from now. And identical results meant the same inputs would give the same answers. And what I'm focused on here is ensuring we get the same input. And one way of doing that is to say all the inputs are as on the Tech Collection DVD of 2021. That's a sort of well-defined object, and you can give it a secure hash to make sure you've got it right. So you can always say it's got a name and a secure hash, but that's an awfully big thing. If you change one file, you have to burn a new DVD to ensure that you've got identical inputs. And the Git version control system, in fact, all version control systems are refined versions of copy. Copy is a way of saying the data at this location is exactly the same as the data at that location. That's the test of copy. The data is the same. And all version control systems, their goal is to ensure that data is reproducible and trees of data, directory structures of data, are reproducible. And there are all sorts of ways of doing that. Backing up is also a way of ensuring reproducibility of data. Now, a content addressable store is rather different because instead of saying the file is as I left it on Thursday evening at this location on the PC, you create a hash of the file, a number, and you use that as a fingerprint to check that on Friday morning you've still got the same file. So if two things hash the same, they are for practical purposes the same. And Git is unusual, not unique, but unusual, in that it uses the hash as the name of the file. So that's why it's called a content addressable store. The address of an object is determined by its content. And Git can not only store a stream of data, but sort of abstract binary data, but can also store things that it labels as trees, a tree of data, or in other words, a directory. And then that way you can store a whole directory tree, and it also has objects it can store that are called commits and tags, and that allows you to build your version control system. So Git's a version control system built on a content addressable store. And for a long time, I've thought it would be quite nice, or at least worth exploring, to use Git's content addressable store as a mechanism for distributing tech resources and ensuring that we have the same resources and ensuring reproducibility. So if you have a Git repository, you can say to a Git repository, give me the object, and if it's a tree, give me the whole tree at this location where the location is a hash. And I'll either say, I ain't got it, or it'll give you the object, and two people should always get the same object, and they won't have to talk to each other at all to check, except to check that they've got the same secure hash. So it's really quite a powerful situation. And I've put a couple of posts into the Tech Live news group, which I suspect we've all seen, starting up on how I see this going. And the main thing, first of all, is that I see pack files as being very important. So the first thing to remember about Git is you have multiple entry points. You can have two trees in it that are completely disjoint. In fact, two commits that in some sense are disjoint in the sense that they don't have any shared history, but they have a lot of shared objects, a lot of shared files. So you can, so to speak, mash up any number of objects into one Git repository and retrieve them independently. So in that sense, it's a bit like a file. You have one tree called work and another tree called home. and they just live independently. But because it's a content addressable store, we only saw the same data once, even if it's at 2 locations. At some point, it might be helpful to explain the concept of a Git bomb. A Git bomb is a Git repository, and when you check it out, it contains gigabytes and gigabytes and gigabytes and gigabytes of data, but the repository itself is only a few hundred K. So that's the sort of compression of data that, or the expansion of data that Git provides, but I'll put that to one side. So a Git repository can store all sorts of stuff, and then there's the question of accessing it. So if we put, let's say for simplicity, all the style files in every version of Tech Live, we can put all of those into one Git repository, and I don't suppose it would be more than a gigabyte, because style files aren't particularly big, because Git compresses everything it stores. And if we update to 2022, we can put the new style files, or rather the changed style files and the different style files, and add that to the repository. And all we have to do is add a new Git pack. That's all we have to do, is drop a new Git pack in, and we've immediately added to our store all the information we've got. It's like having a membership list of a group, and there are some new members in the group. So you add those entries in, and you don't remove the old entries. And you can do that quite successfully because it's content addressable. That content addressable store thing is making everything work really well. And then there's a question of accessing everything. Well, you can put into the store or into a pack a tree-like structure.